All right, guys, Mr. Antonucci here, and in this video, I'm going to walk you through 15 problems to review halfway through the year in calculus. So we'll start number one here. We want to find the derivative, and here we have a product rule with a chain rule. So we have to do the product rule here. So the derivative is derivative of the first times the second plus the first times the derivative of the second. Whenever you have square root, you could do the chain rule on it, do the derivative of the inside over twice the original square root, and the twos cancel. Okay, that's just a square root trick. It only works for square roots. Now, with this, we need to simplify it more because none of the answers line up and they're not adding. So what they did was they multiplied this first term by root 2x minus 3 over root 2x minus 3 so that it had a common denominator with this one. Then both terms have root 2x minus 3. Um, and then the root 2x minus 3 here and this one multiply together to give you 2x minus 3 plus 2x. No, actually just x, not 2x. So this gives you 3x minus 3 over root 2x minus 3. Okay, that's our derivative, which is also choice A in this situation. Okay. All right, moving along here. Number two, we want to find the derivative evaluated at -1. Now, assuming we're not allowed to use calculator here, we'll just take the derivative here. First thing I'm going to do, though, is rewrite this as x cubed plus x to the -1. And then when I differentiate that, you have negative 3x squared plus the derivative of x is 1. And then x to the -1, the derivative, the exponent comes down, and you subtract 1 from the exponent. So this would be negative 3x squared plus 1 minus 1 over x squared. So that when you plug in -1, so they got a lot of negatives going on here, and that can be kind of tricky. All right. So -3 times -1 squared. Be careful, -1 squared is 1. So times -3 gives you -3 plus 1 minus 1, which equals -3. Okay, choice D here is the correct answer in this situation. Okay, now let's take a peek at number 3 here. What point on the graph of y equals x squared is the tangent line parallel to the line 2x minus 4y equals 3? So we got to figure out which point is parallel. Now remember, parallel means you have the same slope. So I want to get the slope of this equation, so I'll solve it for y. So I subtract 2x and then divide by -4. Okay, so I'm only concerned with the slope, so I don't really need to go that far. The slope, or I don't really have to go much further. So I know the slope is 1/2, so that means f prime of c has to equal 1/2 in order for the graph of y equals 1/2 x squared to be parallel to the graph of 2x minus 4y equals 3. So I'll take the derivative. So the derivative of 1/2 x squared is just x. Set that equal to 1/2. So x equals 1/2. Now, with these, it's going to eliminate this choice, and this choice. Now, it wants to know what point on the graph of y equals 1/2 x squared. So I plug the 1/2 in, okay, to 1/2 x squared, and y would equal 1/2 times 1/2 squared. 1/2 squared is 1/4 times 1/2 is 1/8. So we get choice B on that one. Okay. Now, at any point, feel free to pause the recording before I go over the question and work it out for yourself. Now, the graph of y equals that polynomial is concave down 4. Now, which one? Okay, so concavity deals with the second derivative. Concave down means the second derivative is going to be negative. So to do that, you got to find the first derivative, which would be 12x cubed minus 48, x squared plus 48x. The second derivative is going to be 36x squared minus 96x plus 48. Okay, so it's getting pretty complicated here in terms of the numbers that we have, but we can set this equal to 0 and start factoring a little bit. Okay, so we'll go ahead and factor out at 12. So you have 12 times x squared minus 8x plus 4 equals 0. Excuse me, that should be a 3x squared there. And then you need factors here. So the first factors have to multiply to 3x squared. So you know you have a 3x and an x. And then the outers and inners have to multiply to negative 8x or add up to negative 8x. So you'd end up and multiply to positive 4. So you'd end up with negative 2 and negative 2 here. So this term is equal to 0 when x is 3 halves. And this term is equal to 0 when x equals 2. Now, the reason that we're doing this is because we want to figure out where the second derivative is equal to 0. So it's this is actually 2/3, not 3 halves. So 2/3 and 2. Because we want to test a value on either side using the test for concavity, test a point in the second derivative. So I'm going to pick a point before 2/3. An easy one is 0. Then between them, 1. And then after 2 would give me 3. You can pick any number you want. But if I plug 0 into the second derivative, it's going to end up being, if I look at the factored form, if I plug 0 in there, you're going to have 12 times negative 2 times negative 2. Don't really care what the value is. I just want to know what the sign is. So I'd have a positive times a negative, which would be a positive. If I plug in 1, the first set of parentheses is going to be positive. The second set of parentheses is going to be negative. It's 1 minus 2. So you'd have 12 times a positive times a negative, which is going to be negative. Now, don't always assume that the signs are going to change sign, alternate the whole time. So you do have to check 3 in the second derivative. Turns out that's also positive. So the interval is from 2/3 to 2, where the second derivative is negative, and that function will be concave down. And that's choice E for us there. Now let's move on to number 5. We want to find the derivative of cosine squared of x cubed. Okay, so with this one, it might be helpful to write this as cosine x cubed squared. All right, now we're going to do the chain rule here. The derivative of the outside function is the squaring function. So that's going to be bring the 2 down to the power of 1, the cosine of x cubed, times the derivative of the inside of that. So the derivative of the inside there, the next inside would be derivative of cosine, which is negative sine of x cubed. But sine also has a function inside of it, x cubed, which is going to give you, whose derivative is 3x squared. So you have negative 6x squared cosine x cubed sine x cubed. And so this is going to give us choice D. And I'm going to put the parentheses here so we know that the x is cubed in our work here. Okay, so double chain rule on that one. Now, the sixth problem I want to go over says a bug begins to crawl up a vertical wire at time t equals 0. The velocity of the bug at time t is between 0 and 8 is given by the function whose graph shown above. So notice, we have to be careful. This is the velocity function. We want to know at what value of t does the bug change direction. Well, that would be at 6 because at 6, the velocity changes sign. So between 0 and 6, the velocity is positive, and between 6 and 8, the velocity is negative. And at 6, the velocity changes from positive to negative, which means if the bug's crawling up a vertical wire, it was crawling up it for the first 6 seconds and then change directions and climb down it a little bit there. Okay, so no real work, just understanding the concept and making sure we understand that the graph is a velocity graph. Okay, the next one we're going to look at is number 7. An equation of the line tangent to the graph of y equals 2 cosine x at pi over 4 is. So here's another one we have to be careful because um, you may not have a calculator for this question, so it's important to know the special values of the trig functions. So tangent line at x equals pi over 4. We always need two things with a tangent line. We need a point. So I know the x value is pi over 4. So if I evaluate the function at pi over 4, that would be cosine of pi over 2, and cosine of pi over 2 is 0. So that means the point that we have is pi over 4 comma 0. The second thing we need is the slope. The slope of the tangent line is equivalent to the value of the derivative at the point of tangency. So let's take the derivative. So negative sine of 2x times 2. I'm going to put the 2 there. Okay, got to use the chain rule there. And then evaluating this at 0 is 2, or excuse me, pi over 4. It's going to give you negative 2 sine of pi over 2. Pi over 2 is 1, so the slope is negative 2. Okay, so y minus y1 equals the slope times x minus x1, where this x1, y1 is your point, and the derivative evaluated at that point is your slope. So now y minus 0 is just y, and so for this one, the answer is just e. Okay, so we're almost halfway through these questions here. Again, remember, you can always pause the video, work it out on your own, and then try it. So number 8, the graph of the derivative of f is shown, so be careful. The graph they give you is f prime. Which of the following could be the graph of f? A couple things I want to notice here. The derivative changes sign at negative 2 and 2. So it goes from negative to positive. So I know f will have a relative min at x equals negative 2. And the derivative changes from positive to negative at 2. So f is going to have a relative max at x equals 2. All right. Another thing is you can look at increasing and decreasing. So like the derivative is increasing before 0. So that tells me that the second derivative is positive, or the graph of f is going to be concave up. Similarly, the derivative is decreasing for x greater than 0. So I know the second derivative is negative for x greater than 0. So the graph of f would be concave down for x greater than 0. So if I know these characteristics, I'm going to have a relative min at negative 2, relative max at x equals 2. These two are out because they're linear. This one is out because the max and min are not at 2 and negative 2. Now, E and D both have extrema at 2 and negative 2. But what we say? We said at x equals negative 2, you're going to have a relative min. So it's this one. Also, it lines up with the concavity. We said before x equals 0, the graph's going to be concave up, and then it's going to switch to concave down after x equals 0. So this 8th one is choice E. Moving on to number 9, let f be the function defined for all real numbers. If f prime equals that mess there, then f is decreasing on which of these intervals? So it looks like, so a couple things. We're going to have critical numbers when x equals 2, because that makes the derivative undefined, and we know f is defined for all real numbers. And the numerator is going to be 0 when x is plus or minus 2. So I know I have critical numbers at -2 and 2. So there are no other critical numbers. So I know that I can check values before, between, and after. So if I check like -3, um, I know the numerator is always going to be positive because you're squaring it, you're subtracting it from 4. So whether it's positive or negative doesn't matter because you're going to take the absolute value of it. So the numerator is always positive when I plug in -3, okay? The numerator's positive and the denominator's going to be negative, which means this interval is going to be negative. So -infinity to 2, -2. Okay. Now, that doesn't look like it's any of the choices there. So we have to keep going. All right, we'll test 0. If I plug 0 in, um, I'm going to have a positive over a negative. So it's also decreasing here as well. So -infinity to 2. Now, if I plug a number in larger than 2, let's say +3, then the numerator is positive and the denominator is going to be positive as well. So the interval -infinity to 2 is actually the answer in this case. And it's okay that the derivative is 0 at -2. We can still include that on the interval that the function is decreasing because you decrease over an interval and it would go through that one point. Okay, so we can list that as one interval. All right, number 10. Let f be a differentiable function such that f of 3 equals 2, f prime of 3 equals 5. The tangent line to the graph of f equals 3 is used to find an approximation to a 0 of f. That approximation is, so we got to get the tangent line. All right, so from this, f of 3 equals 2, I know 3 comma 2 is a point. That's my x1, y1. From the derivative, I know that my slope is equal to 5. Okay, so the tangent line is y minus y1 equals the slope times x minus x1. I'm going to solve this for y. So you have 5x minus 15 plus 2. So y equals 5x minus 13. So that's the tangent line. Now, I'm going to use the tangent line to find an approximation to the 0 of f. So check this out right here. So if I look at the graph, I don't know what it looks like, okay? But I know this point 3 comma 2 is on it, and I know that the tangent line has a slope of 5 at that point. So if I go down 5, back 1, I mean, my line's going to be like this, okay? So I don't know what the graph of f looks like, but what it's asking me to do is like, let's pretend the graph of f goes like this or something. Okay, we're going to approximate the 0, the function, by figuring out where this is equal to 0. So if I solve that for x, I get 13 over 5, which is 2.6. So we get choice C here. Okay, you didn't need the graph at all. I was just helping there, hoping that helps. Now notice the graph that I drew didn't even have an x-intercept, so that's probably a bad example. Maybe the graph goes like this or something. I don't know. Okay, we don't know. They ain't given us enough information. All right, so this one deals with limits. The graph of the function is shown above. So make sure we understand that this is the graph of f. Which of the following statements is true? The limit as x approaches a is equal to the limit as x approaches b. That's not true because the limit as x approaches b does not exist because you have different behavior from the left and right. The limit as x approaches a equals to, that one is actually true because the limit does not depend on the function value. And as x approaches a from either side, the y value also approaches 2 from both sides. C is incorrect because only the one-sided limit from the left will equal 2, and D is incorrect because only the one-sided limit from the right will equal 2. And E is incorrect because the limit does exist. So this one is just choice B. All right, number 12. So you have this implicitly defined function. We want to find the second derivative at the point 4 comma 3. I'm going to show you a quick trick for this one. So if you differentiate that, you would get 2x plus 2y times dy dx equals 0. Remember, when you're doing implicit differentiation, you treat y as a function and use the chain rule. So dy dx is going to be negative 2x over 2y, which is negative x over y. Now, when I go to get the second derivative, it gets kind of complicated. I always like to do the bottom first, which is going to be y squared. And then we're going to do the quotient rule here. So the derivative of the top is negative 1 times the bottom minus the derivative of the bottom, which is y prime, times the top, which is negative x. Now, here's where we can put the trick in. Don't simplify this because we're evaluating it at the point 4 comma 3. So if I want to evaluate the derivative at the point 4 comma 3, this is going to give me negative 4 thirds. I can use that for the value of y prime right there. Okay, so it's negative 1 times the value of y, which is 3, minus the value of y prime, negative 4 thirds, times the opposite of the value of x, which is 4, all over the value of y squared, so 3 squared. Okay, so some simplification is going to happen here. You're going to have negative 3 minus 16 over 3 over 9. Okay, I'm just going to multiply the whole numerator here by 3 and the denominator here by 3, getting kind of tight with the work. But if this distributes here, I'm going to have negative 9 minus 16 over 27. So this is going to give me negative 25 over 27. And that gives us choice A there. Okay? So took the first derivative, set up the second derivative using the quotient rule, plugged in the point because I'm going to evaluate it. I'm not worried about algebraically simplifying it beyond that point. Okay? All right, number 13. If y equals 2x minus 8, what is the minimum value of the product xy? So I'm just going to call P the product xy. If I substitute y equals 2x minus 8 in there, I'd have x times 2x minus 8, which is 2x squared minus 8x. I can use any number I want for x because they didn't give me any other constraints. And it's not like a shape or a real life situation, so positives and negatives would both be valid. If I take the derivative, you have 4x minus 8, set that equal to 0 to get my critical number. You'd have x equals 2. I'm going to take the second derivative, which is 4, which is always greater than 0. So that means the graph is concave up. Now, the critical number is 2. By the second derivative test, p double prime of 2, so I'm plugging the second derivatives, or excuse me, I'm plugging the critical number into the second derivative. The second derivative is always 4. So we're concave up at a critical number. That means that this is a relative minimum. Okay, there are no endpoints because the domain goes on forever. There's only one critical number. And also, if we did the first derivative test, we'd see that the first derivative changed from negative to positive at x equal 2. Now, 2 is not the answer, and 4 is not the answer because it wants to know what the minimum product is. So all we have to do is plug 2 back into the product equation. We can plug it in right here. So P of 2 is going to be 2 times 2 times 2, 2 times 2x minus 8, which is going to be 2 times negative 4, which is negative 8. And we have -8, which is choice B for this one. All right, just two more, then we'll wrap it up here. Let f be the function such that we have this limit here. Which of the following must be true? F is continuous, f is differentiable. The derivative is continuous. So notice that this is the limit definition of the derivative of f for when x equals 2. What this statement is really saying is that f prime of 2 equals 5. Now, since the derivative exists by this limit statement, since the limit exists, and the limit is the limit definition of the derivative exists, and the function, the function is going to be differentiable at x equals 2 because the value of the derivative exists. Since the function's differentiable, there's a theorem that says anytime a function's differentiable, it's also continuous there. So we know it's continuous at x equals 2. What we do not know, however, is if the derivative is continuous there because we don't know any other information except for x equals 5. So for this one, it's choice C, 1 and 2 only. The derivative could be continuous there, but it's not, it doesn't have to be true. Notice this says must be true, not could be true. Okay. And the last one, let f be function absolute value of x. Which statements about f are true? F is continuous at 0, f is differentiable, f has an absolute min at x equals 0. Well, if you remember the graph of the absolute value function, looks like this. All right, it's continuous at x equals 0 because the limit as x approaches 0 of f of x equals f of 0, and those are both equal to 0. So it's continuous. However, since we have a corner there, the function is not differentiable at 0, but that is the absolute min of the function. So it's 1 and 3 only, which is choice D. All right, guys, that's it for this one. Hopefully I'll be able to, hopefully that was helpful to you. Let me know if you have any questions. Take care.